So let's talk about what it really means for things to be proportional and inversely proportional. So let's start out with proportion, and we'll start out with kind of a logical example of what it really means in everyday life. So let's just say you have 10 seconds. So a car travels from this point A to point B, point A to point B in 10 seconds. So we'll call its distance d1, and it was traveling at a certain constant speed. Let's call it v1. You can call it s1. You can write out the word speed. It doesn't really matter. So in 10 seconds, it went a certain constant speed, and then that total amount of distance covered was d1. So now we know logically that if it was traveling twice the speed, it would be able to cover twice the amount. So it was going 2 times the speed. Let's just say we run the trial again, and everything's held the same, same road conditions, same everything. Well, now it covers here to here, here to here. Covered distance, same amount of distance once, twice. So the total was 2 times distance. We can kind of see this relation. You know, that's what it really means for two things to be proportional. When something changes by the same factor as something else. So how do we write that? So we write v1, and this is the proportional symbol, proportional to d1. Or if you just want to write it as v, speed is proportional to its distance. And we know that from everyday life. So what does this really mean? This really works when you're dealing with multiplication or division. It's these factors in front that really matter. That's what you can do with proportional things. So you take your speed. If you were going half the speed, then you'll cover half the distance in 10 seconds. It doesn't work. You cannot do this with adding or subtracting. You can't say that if you increase your speed by one whatever unit you're using, meters per second, kilometers per hour, that you increase your distance by one. You can't generally do that. It's only factors. So any number that you multiply or divide by one, that you have to multiply or divide by the exact same number, same one. So what are things that are inversely proportionate? Well, inversely proportionate kind of have the same structure as this is, well, let's start out with the same kind of graphical and logical example that we had. So let's say you have a 100-meter distance. So from here to here. That doesn't change. You will always do 100 meters. Now, you're going to do this in a certain amount of time. Let's just say t1. In our earlier example, we kept it as 10 seconds, whatever time it was, with speed v1. Well, we know that if we were traveling, so same distance again, if we were traveling at half the speed, let's say for example, it would take twice the time. If you're running a 100-meter track and you run half the speed, then it's going to take you twice as long. We know that logically. And when you have this kind of relation where something changes by, like this factor, let's just say 2, and the opposite changes by an inverse amount, so 1 over 2. So let's just say something changes by a factor of 3, and something else changes by 1 over 3, then we know that these two things are inversely proportionate. So how do we write that? Inversely proportionate. We say that v inversely proportionate to 1 over time. So if we're going double the speed, then it'll take half the time. And these kind of understanding of what these really mean is essential for moving forward when it comes to doing actual examples. Like how the next video we're gonna do an example on gears. Kind of have to really understand what things that are inversely proportional, what that really means. So in the example of gears, we're gonna find out that the the speed that the gear is turning, so revolutions per minute, is inversely proportionate to its diameter. So how big the gear or pulley, whatever, really is. And all that just means is, what we have here. So if it was moving twice as fast, 2 times the RPM, then it must have half the diameter. And we'll see that in the next example.